Hello everyone, welcome to the next video of data science playlist on TechSatva. Next topic is data science, preparing to model the data. This dwells into the essential steps of preparing data for machine learning models, from partitioning and validating your dataset to balancing training data and establishing a baseline. We will cover key strategies for creating a robust model foundation. So start the story so far. So what we have covered so far is the data collection and data cleaning, right? So what was the data collection? Gather relevant data from diverse sources, consider the quality, completeness and potential biases of the data. Next is data cleaning. What was data cleaning? It's address missing values, inconsistencies and outlier, ensure the data is structured for analyzing and modeling, right? So next is partitioning the data. How do we partition the data for the analysis? First is training data, used to train the model, learning patterns and relationship within the data. Next is validating data, used to fine-tune the model hyperparameters and avoid overfitting to the training data. Next is test data. So what is test data? Reserved for evaluating the final model performance on unseen data, right? Next is validating your partition. That you have done with the partition, now you have to validate your partition, right? So first is size. The size of each partition should reflect the size of the data. For example, 80% training, 10% validation and 10% testing. Now distribution. The distribution of features within each partition should resemble the overall distribution of the data to avoid bias, right? This is balancing the training data set. So imbalanced data and balancing techniques. When one class has significantly more data than another, it can hinder model performance. Now balancing techniques like oversampling, undersampling or synthetic minority oversampling technique, SMOT, can be used to address imbalances. So moving on to next, establishing baseline model performance. Model selection, metric selection. What is model selection? Choosing an appropriate model for the problem based on data characteristics and business objectives. Now what is metric selection? Defining metrics like accuracy, precision recall or F1 score to evaluate the model's performance, right? Next is partitioning data in Python. Now we have done with the partition. Now we will learn partitioning data in Python. So first of all, we will import libraries, those necessary libraries that we are using partitioning. Like import necessary libraries like Scikit learn for data manipulation and model learning. Second is partitioning function. So what is the partitioning function? Utilize the train_test_split function to divide the data into training, validation and testing. Now third is stratification. Consider using stratify argument to preserve the distribution of classes in each partition, right? Next is partitioning data in R. Now we have done with the partitioning data in Python. Now we'll learn about partitioning data in R. So first one is install and load packages. Okay, so install and load necessary packages like caret for data preparation. Now create index. Use the create data partition function to create indices for dividing the data. Now partition the data. Use the generated indices to separate the data into training, validation and testing sets, right? Next is data science, a summary. Now moving on to the summary that we have covered till now is data preparation. We have done with the data preparation, we have done with the data partitioning validation, balancing training data, baseline model performance, Python implementation and R implementation. So that's all for today. Let's move on to the next topic in the next video. If you have any doubts, any queries, please do comments in the comment section. Please subscribe to my channel Tech Sattva and please press the bell icon for the notification. Thank you.